start the recording there. So, welcome to server-side programming Comp 10-216, yes. So, as I mentioned, this course, the language of study will be PHP. What does PHP stand for? Anybody? So it has actually changed since it was invented back in the 90s. Originally, PHP stood for Personal Homepage. It was a way of personalizing a homepage. You used to talk about things like home pages back in the 90s. These days, PHP stands for PHP Hypertext Processor. So the P in PHP stands for PHP, which should give you some kind of a flavor of the language. So, of course, I know everybody would love to be taking the Node.js version of the course that currently doesn't exist, but will exist by the end of the summer, hopefully. Unfortunately, we just don't have it. Otherwise, I would give it to you. Consequences be damned. But, you know, it just simply isn't written, so I can't give it to you, unfortunately. That being said, PHP is still a good and useful language to learn. Obviously, there's a reason that we're moving things over to Node.js. Node.js is very popular. But most of what we will be learning in this class will be server development as such, right? A lot of what we'll be talking about is language independent, and this is very important. These are the skills that you will be able to transfer, you know, from PHP to Node.js, from Node.js to whatever comes next, possibly even Next.js. So we will focus on what is a server, how does it run. We will certainly, you know, be using PHP as a language, but all of the various particular things that we'll be doing in PHP will have some iteration in the new languages. Okay? So, so that's kind of where we're at. Any questions so far? Good. All right, well, if you've never had the pleasure of my acquaintance before, I flatter myself to say, I am Dr. Nicholas Moore, and I will be your instructor for the first half of this semester. Jonathan Graham will be your instructor for the second half. I checked, and there is no room change halfway through. Sometimes there's a room change halfway through. It doesn't seem so at this point, but always a good thing to check when the halves switch over. Make sure they didn't sneak a room change in, right? So, this is the room. It's a little on the small side, but so is the class, so it works out nicely. So, let us discuss the syllabus. So, using the PHP language, you will be introduced to techniques for writing solid, maintainable code, to deploy dynamic web applications and solve common real-world problems. Topics will be input validation, database interfacing, session and user management, and security, as well as covering pure server-side application architecture. We will also look at hybrid approaches such as Ajax and WebSockets. Welcome, welcome. So, our grading scheme for this course, 40% of your final grade will be given across four assignments. 30% of your final grade will be the midterm test. 30% of your final grade will be the final examination. In order to pass the course, you must meet the following conditions. Number one, Your calculated grade, including all of the 3 categories above, must be greater than or equal to 50%. And, number 2, the weighted average of the proctored component of this course, that is, the midterm and final, must be above 50%. If condition 2 is not met, your final grade will be capped at 45%. So, at this point, this is a 3rd semester course, you've probably seen policies of this sort for a little bit now. This will not be the first time you've run across it. However, it is useful to sort of give you the reasons that this is the case, right? Basically, the problem with the assignments. The assignment has to be something that's reasonable for me to give to you to accomplish, working on it, for some number of hours at interspaced intervals over a period of 2 weeks, right? This means that the assignment it must be small, self-contained. It has to be kind of bite-sized and a little bit crispy and chunky, like a packet of potato chips, right? Unfortunately, these are precisely the sorts of problems that the infernal AI is good at solving, small ones, right? So, it is an unfortunate tendency that students of late, and honestly you can hardly blame them, because, you can blame them, and I often do when it's egregious with academic integrity citations. But given the environment that we live in at the moment, and the just constant hammering that you guys get, even from your IDEs, use AI, use AI, use AI, use AI. Oh, if you don't use AI, you're not going to be on the train, you're going to not have a job, you're not going to be employable if you don't use the AI. It's like, if your company doesn't use AI, it won't exist in 3 years. All of these types of things, right? And all of these things are, broadly speaking, marketing, right? We exist in a world with multi-level marketing, which means that even things like scientific papers are bought and paid for by companies, right? To sell product. And the product they're trying to sell you is artificial intelligence, quote unquote, which, by the way, is also a marketing term. What is it really? Fancy autocomplete. It has always been fancy autocomplete. It will always be fancy autocomplete. What it really is it's a plagiarism machine that lies. That's what the artificial intelligence is. So, it is unfortunate, but many students, when presented with the temptation, ooh, here's a thing that can do all of your work for you and solve your assignments for you. Unfortunately, many students fall victim to this erroneous approach. And due to the sort of inherent nature of the text generation that the thing is doing, it's also very difficult to catch AI using automated means. This was I kind of view this as a problem they intentionally didn't solve, was the sort of programming problem of, well, how do we actually tell if something has been generated by AI? That would be a useful thing to know, right? But they kind of intentionally didn't solve the problem, in my view. So, the problem is that 40% of the grade can be, and is often, unfortunately, completed trivially by students by using the artificial intelligence schlock. And there's really not much I can do about it, because often, often the solutions they're plagiarizing look pretty good. Although, it also kind of depends on the complexity of the assignment, right? As the course goes on, the assignments tend to get more course-specific and increase in scale and complexity. And as that happens, it's not that the AI produces solutions which are wrong, necessarily, but it produces solutions which are obvious. Obvious for someone who's looking at it, to see whether or not it's AI or not, right? Ask my sections of client-side and Java that I was teaching in the winter semester. You know, everything was hunky-dory until about assignments 5 and 6 in Java, and then it's like, oh, the things started using lambdas, right, and all kinds of things that the students don't know how to use. At the end of that semester, I wrote up 16 students for academic integrity, which, incidentally, is larger than the actual population of this class. As things go along, it will become increasingly obvious if you're over-relying on it. But the most obvious instance, the biggest tell of whether a student is overusing not only AI, but sort of internet aids in general, you know, even things like Geeks for Geeks. There will be a very wide disparity between your assignment scores and your test scores, right? If you're scoring very, very well on assignments, but it comes to a test, and you're, you know, not doing very well at all, particularly if your test scores are, you know, maybe say sub 30, 35%, where you're getting like 90s, 100s on your assignments, it happens frequently. Then that's a very clear indication to me that however you're completing your assignments, you're not actually doing the work. Because if you were actually doing the work when it came to the test, you'd be able to write a test. And that, my friends, is why you must pass the tests in order to pass the class. Tests are in a controlled environment. We do pencil and paper tests, right? Yes, pencil and paper tests. No IDEs to help you with autocompletes. The information must reside in your own brains. So, when you write stuff, when you do the practice problems, you must be the one to practice. And if you don't, it'll show on your test scores, and you'll fail the tests, and therefore the course. So, that is your incentive. Unfortunately, that's the best that we can do at the moment in terms of incentive to actually try to encourage you to do the work yourself, to, you know, hold the exam over your head like the sword of Damocles. But, that's what we got. So, it's tests. Tests are how we are going to evaluate you as to whether you learned anything. Make sense? Any questions? Yes.
Is there like this problem? Paper-based tests has been like long. It's been a while. Is there like any? I'm just curious if there's actually any progress on finding ways to make tests computer-based and like integrity as well.
There has been what you might say the opposite of progress. Like we used to use what's it called? Respondus lockdown browser, right? Unfortunately, I can't reveal specific details for fear that the thing is used in other classes. I don't want to be responsible for spreading the information, but it's come out recently that there are like some very basic hacks for Respondus to get around it. So as far as it's been my position for a while that like the online test is dead. Anybody who uses it is a fool. That's been my position for some years now. And I used to do quite a bit of online testing, but I was kind of doing it during COVID where I had no choice, right? It's online testing is a joke, and anybody who's serious about academic integrity can't possibly use them, in my view. So, paper tests. You shall have a piece of paper, you shall write on it, I shall look at it, and decide whether you know anything. Any other questions? Yes.
Are you anti-AI?
Man, that's a good question. Am I anti-AI? See, the thing is, I do use it, right? But I don't use it to generate code, right? Like, if you consider what the thing's good at, right? If you're making the generous case for AI, it seems to be like the next step in search algorithms, right? So the sort of question that you would previously present to Google, right? You would, be provided with a whole list of links, often a few Stack Overflow articles. It's often somewhat tiresome work to comb through a Stack Overflow, log to see what the actual thing that'll work is. AI seems to be better at summarizing those types of things for you. If you have a specific problem that and you were going to Google it anyway, doing it in AI seems to be a bit faster. But again, I generally think that a lot of the stuff that's said about AI generating code is not nearly as good as it claims to be. There's kind of this meme that's been around for a while. It's like, we fired half of our developers, but we had to double the size of the testing team, right? And that's actually kind of been true, right? And by the way, if you're interested in becoming a senior developer at any point, the route to senior developer normally passes through the testing department at most software companies. That's part of the culture. So AI generates code. It may often work on the surface of it, but if you start poking and prodding at it, you'll find that it's not nearly as good as it appears on the surface. Unfortunately, it kind of hacks this tendency that human beings have in their brain. It's kind of like a good enough kind of heuristic, right? It's like if you're given an answer to a question, it's not necessarily the best answer, but it's good enough, right? You'll tend to accept that good enough answer and not dig into it too deeply. This is what happens with AI a lot of the time, I find. As I have said, it's fancy autocomplete, right? Is it a good idea to autocomplete basically your whole program? Probably not. So, generally speaking, the people who are the greatest advocates of AI tend to be senior developers, right? A senior developer already has enough experience that they know very specifically what questions to ask, right? They are able to sort of work in concert with the thing, right? To a far greater degree than any of you would be able to. And the key factor that you folks are missing is knowledge of the discipline and the domain, right? There's this kind of inextricable problem that exists in programming languages, which it's been something that we've been fighting for, basically since the invention of programming languages. In order to create a program, you have to give the machine instructions, right? Those instructions, however you encode them, have to reach a certain level of complexity in order for the program to do what you expect it to do, right? There will never be a programming language that frees you from the burden of clarifying your ideas, right? You will always have to think precisely to produce a program. So what the AI does, the way that it's trying to get around this, is by plagiarizing code it finds online to fill the gaps in your knowledge, right? Which it can sometimes do successfully, but it hits its limits pretty quickly, right? The other thing to keep in mind about the AI is that it might at some point, and I know they don't want you to think this, but it might go away, right? Local artificial intelligence installations, like running on your computer under your desk, those things are here to stay, but they're heck of a lot less powerful than the great big models. Here are some facts for you, right? OpenAI, right? Do you know what its gross revenue was? How much money did OpenAI make last year? In total, how much money did they make?
Well,
Anybody care to guess?
I think it was like $200 million.
$200 million? A bit more than that. $21 billion is how much OpenAI made. Now here's a question. How much did that operation cost? Because that sounds like a lot of money, right? Well, the cost of computation alone, so this isn't staff, this isn't tax, this is just the cost of running the computers, $500 billion. $500 billion. So, basically, OpenAI pays $20 for every dollar it makes in compute cost alone. Now I ask you, sir, is that a sustainable business model? No. So, and do you think people would still pay for their AI subscriptions if they woke up tomorrow and it was 20 times what it was before? Probably not, right? So, we'll see. But it's a bubble, and the bubble's going to pop sooner or later, right? And when the bubble pops, we don't know what it's going to look like afterwards. We don't know what's going to be left. But let me tell you, there is one thing that, a stock market crash won't be able to take away from you, and that is your own brain. So always the best investment is in the wetware rather than the hardware. All right? So that is roughly speaking what I think of the AI. It's I generally, I don't even necessarily find the little tech demos impressive. People around the office are like, ooh, look how well it can do chess. It's like, yeah, chess. Everybody and their monkey has a chess implementation. Show me something unique. Show me something that's not 1,000,000 times on the internet. And it can't, because everything it does is 1,000,000 times on the internet because it's a plagiarism machine that lies. That's what it is. So, that's my personal perspective. So, shall we discuss the itinerary for the course? The topics of study? So I have you for the first half, which means that primarily we are going to be going through the basics of the PHP language. And believe me, its basics aren't that basic. We're going to discuss user input, file I/O, and then we're going to have the midterm exam, basically corresponding to the last week of the first half. The the mid-semester break is not counted on this itinerary because it kind of moves depending on what semester you're in and how the calendar falls. So yeah, somewhere in the middle of there is our mid-semester recess. So, for me, you will be responsible for 2 assignments, assignment 1 and assignment 2. Assignment 1 is, I think, currently posted. You can take a look. There you go. Introduction to Server-Side Programming. I don't necessarily recommend jumping into that just yet. I should probably tell you what this stuff even is and does. But if you're interested in what the rest of them are, there you go. This one's kind of cool. I like it. You make a little video game using databases and stuff. So, yes. Wait, no, Solus. Solus! There we go. Once Jonathan is in charge of you, he'll be talking about cookies and sessions, databases for 2 weeks, MVC architecture, REST APIs, and then last week's exam review, and then the exam. Any questions? So, on the subject of generative artificial intelligence, we're using the AI-ready framework, quote unquote. There are 5 levels of AI use. Each assignment will indicate to what degree you are permitted to use AI on the assignment, right? So, for example, level 1 is AI prohibited. No AI tools are allowed whatsoever. Students must complete all aspects of the assignment independently. Like, the tests are this level, right? AI restricted. AI can be used for basic tasks such as error checking, code analysis, comment, and grammar checking, but must not contribute to content development. The focus remains on individual understanding. So, if we take a look at our first assignment, just as an example, you'll see that this has been labeled as a level 2 in terms of AI use. So, taking your code, plugging it in, saying, I'm having this bug, can you see what the problem is? That's the sort of thing we're talking about at this level, right? Must be stressed though. I'm finding more and more students are abstaining from artificial intelligence use for ethical reasons. You are in no way and at no point required to use artificial intelligence for this course. So yeah, does this make sense? Good, clarifies expectations. The goal is to clarify expectations. Yes. So, code standards. You must understand that we are programming servers here, right? Servers are tricky beasts. You have to be worried about security. Security must always be at the top of your mind. Part of the problem with the AI when it comes to security, when it was trained on the code that's in the internet, it was not trained on a data set of verified solutions that are security compliant. A lot of the time, it will produce code that makes big errors in security. Now, errors in security are a big deal for a server. We're talking about code that would allow your database to be breached, in some cases. Code that allows cross-site scripting attacks to be executed. These types of vulnerabilities are often introduced by artificial intelligence, and if you are a student who has been over-relying on the AI, you're not going to know what you're looking at, you won't realize that it's a security vulnerability, and basically you'll send me assignments where I can blow them apart with security exceptions, and you won't like your grade, basically. Basically, if I can hack your assignment, given that I'm a very moderately skilled hacker, and by moderately skilled hacker, I mean I'm not a hacker at all, I just know a couple of things, a couple of obvious things I can do to try to break your code. If I can break your code in terms of security, you're not going to like your grade. Security is very, very important, right? I'll give you a good example. Reasonably early in this course, we're going to be talking about a function called filter input. Now, the filter input method, man, I've been teaching too much Java. Everything's a method now. The filter input function, it takes a couple of parameters that I'm not really concerned about. We'll learn about them. But the final one is the type of validation that you're supposed to be performing, right? So, in a lot of cases, it'll be something like filter validate int, right? Or there are other ones for strings. There's one for every data type, right? Anybody care to guess what happens if you just leave it off? You call the function without telling it what filter to use. Something strongly not good. Yes?
It just accepts everything, like without.
Yeah. Yeah, it defaults to a filter that's actual name is filter unsafe raw. So if you're using filter input and you don't provide that third parameter, you just leave it off, you're actually like in a worse position for security than if you did nothing at all. Because it looks like you're doing something, but you're not. Right? And this was like a new low for me for the AI and like stuff that people submit on their assignments. Like I got a non-trivial chunk of student submissions that were doing things this way, and I was like, oh, that AI doesn't know how to program PHP, that's for sure. So this is a problem. This is another reason why even if you are using the AI, you need to be examining the code very, very closely and know what you're talking about. Because again, that's a problem. That's like, this one particularly, filter input, is like, this is like your first wall of defense against many types of attack, including cross-site scripting attacks. So that's strongly a problem, strongly a problem. I've also seen code that leaves the, like, in this course, as with a lot of courses, there's a particular way that I'm trying to teach you to do things, right? Despite the fact that PHP is a bit of an old language, the contents of the course are the most current, most specific, security valid way of doing PHP. The course has been recently reviewed and is in fact being taught this semester by Mr. Jonathan Graham, who is actually a cybersecurity analyst. Like, he's an actual professional guy, right? He also knows personally one of the people who invented PHP, which is kind of cool. Ask him about that ask him about that in July. Yeah, like, the AI writes kind of horrible code on top of it. So, okay. I'll give you one more example. There was a social media site in the news, I think this either last year or the year before. It was kind of a horrible thing because it's like reverse social media. It's like you make profiles about other people. And it's like, great concept to begin with, right? But they had a bunch of like real problems because it turned out that like they were doing things like storing the profile photos of all of the users of the website in a publicly accessible directory on their main server. And like, anybody who knew anything wouldn't have done that, right? My view had to be AI. That one had to be AI. So yeah, be very wary. Be very wary of the mechanical beast, because it's not your friend. Computers aren't your friends, right? If you learn nothing else from this class or me, learn that. The computer is not your friend, all right? At best, it is a tool, and at worst, it is a saw that you can cut your own arm off with. So, all right. Academic integrity, don't cheat, all right? Cheating also in this course means using AI in a way not specified. So, you know, if it's a level 2, but you treat it like it's a level 4 or a 5, that's an academic integrity citation. In general, it's that and copying code from miscellaneous internet sources. But, you know, basically instances of lazy cheating have kind of mostly moved over to AI at this point. Late work policy. If your work is late, it will be deducted 20% per calendar day if it's late, up to a maximum of 100% of the assignment. Assignment extensions will be in accordance with the official accommodation plans or notes of absence obtained from student wellness. So, if you want, well, you know, if your laptop dies 2 hours before submission, send me an email, you know, I can be reasonable, right? But in general, if you're asking for extensions because of illness, I'm going to expect you to talk to student wellness, right? And if it's late, there will be a penalty. Okay? So, CS Unix, that old dinosaur. Submissions will need to be made to CS Unix and to Canvas for your assignment to be considered a valid submission. All right? I'm assuming pretty much all of you have done client-side, right? Basically, it's the same rules as client-side. Make sense? Are there any questions so far? All right. Yes?
For assignment extensions on assignments, is there like any, apart from say you're ill or laptop technical difficulties, things like events, is there any exceptions
No.
that fall under?
Nah.
So say, just example, say a family member is getting married and that, or less.
If your family's getting married, I'll expect you to do the assignment the weekend before.
Okay.
You get 2 weeks for the assignments, so,
Oh,
yeah. If it's, especially if it's like foreseeable things or appointments, I'm going to expect you to manage your time. Any other questions? You got a wedding coming up?
Not
Yeah.
anymore.
Just an example?
Yeah.
Yeah. In our family, there is a wedding coming up, a reasonably high-profile one at the end of May.
Congratulations.
Well, it's my wife's cousin. Yeah, it's nice. Love is nice, you know? It's nice when people get married. Alright, so, you guys don't need to see instructor information. It's all boring, don't worry about it. So, shall we commence with the course then? Alright, so, this, I do a lot of teaching on the board. If you've never, how many people have done that before? I seem to recall you two back there, yeah, you as well, maybe. Yeah, Well, you'll get used to me. Or you won't. Anyway, even if you don't like me, you only have to put up with me for like 2 months, so. There you go. It's okay. I know I know, you know, you can't win them all, right? So. Servers. Clients and servers. In order to program servers, you have to know what one is, what it does, how we use it. It's hot in this room, isn't it? I think this thing on the... This either turns on the heat or turns on the air conditioning. I'm going to try it. Let me know if that's the heat. So, yeah, I can't tell. That's kind of just like the basement of E-Wing's summer class experience. Come in a t-shirt. So, clients and servers. Is this gonna work? Let's see. Yeah. The client and the server. Important question. When communication happens between the client and the server, who initiates communication?
The client,
The client. When does the server initiate communication?
when it gives a response. Wait, what?
Well, it's not initiating communication, then it's responding to communication. When does the server initiate communication? It's a trick question. It doesn't. Never, ever, ever. Always client first. Always client first. Very important to understand. If the server had the ability to connect to clients, it would be able to do things like push data to them without the client requesting it, which is a thing it can't do. That becomes important later on. All right? So, client sends request to server. Request. Server sends response to client. Okay. So, question. What are we requesting?
Data.
Data. Sure. We can be a bit more specific than that, though. When you load a web page, what are you loading? The first thing you load. Yes?
HTML files.
The HTML file. Very good. So we can request, for example, index.html. Very good. When we request the HTML file, we are requesting a remote resource. Remote resource. Index.html is a file that exists somewhere in the server's file system. Right? We request this file, server tries to find the file. If it does, it sends it along. It sends it along. If it doesn't, it sends a 404. Right? 404 is the return, the status code for file not found or resource not found. Right? So, this is a very classical view of servers called a file server. Why is it called a file server? It's a server that serves files. Right? So this is kind of your classic view of the internet. This is your Web 1.0 view. Right? Web 2.0 is API calls. and all of that stuff. We'll get into it towards, actually probably it'll be mostly Jonathan that gets into it with you. For us, right here, right now, we are concerned primarily with sort of the Web 1.0 view. It's important to understand that Web 2.0 was built on top of Web 1.0 without changing any of its fundamental infrastructure. So the way that Web 1.0 works is the same as how Web 2.0 works. It just has a few more options enabled that were there already. So we're just choosing to interpret the data a little differently. So, okay, web servers. Web servers are useful. For a period of time, that's what the internet was. You had a bunch of HTML files. Anybody know what HTML stands for? Yeah? Oh, sorry, I thought your hand was up. Anybody? HTML? Yeah?
Hypertext Transfer Protocol.
Ah, that's HTTP. Yeah, HTML, yeah.
Hypertext markup language.
That's right, hypertext markup language. So, does anybody know what hypertext is? If we're writing a markup language for hypertext, we should know what hypertext is, right? Hypertext is text containing hyperlinks. What is a hyperlink? Well, back in the day, back in the late 80s, early 90s, when brontosauruses still roamed the earth, you had two kinds of links. You had regular links and you had hyperlinks. Regular links linked within a document. Hyperlinks linked to other documents. Right? So, good example of a link inside of a Wikipedia article, the sort of table of contents thing, you can click on a thing, go to a different section of the same page. That's a regular link. Google, hyperlinks, right? So hyperlinks, links to other pages, HTML, hypertext markup language. So this is the original conception of the internet. It's kind of a halfway between the idea of like a library where you're going along browsing, pulling a book off the shelf, reading it, putting it down. And it's like that if like the book you opened, you could click on a thing and it would take you to a different book in a different shelf in the library, right? This is kind of the original conception of Web 1.0. And then JavaScript happened. People were like, well, these are programs. Maybe we could send programs over the internet. And it's like, yes, in this very early stage of the internet, everybody who uses the internet is a university professor and definitely wouldn't hack anybody. So yes, this is a fantastic idea. We should be able to send code over the internet. So JavaScript was born. Around the same time, people were like, wait, hold. What if the server itself could have programs on it? Well, server-side programming was born in that instant. You may think that PHP is the oldest server programming language that exists, but it's not. There was an earlier one called Perl, P-E-R-L, which basically invented regular expressions, which are a thing that you probably shouldn't use because you probably don't know what they... Actually, regular expressions are a thing that I often catch people on plagiarism for because they have no idea how they work. So my recommendation is don't use regular expressions. So basically, this is the idea, right? Maybe, rather than asking for an HTML file directly, maybe we want to run a script. Index.php. Says the server. Well, I see that I do have a PHP file sitting there in my hard drive, but because this is a script, I have attached to me a thing called the PHP interpreter. That box isn't big enough, that's okay. So, when the PHP file is requested from the server says, okay, let me just process that there right there for you. So, in goes PHP file. Out comes output file. Right? The output file believes itself to be HTML in the original Web 1.0 version of PHP. These days, you may also have to worry about things like JSON. What does JSON stand for? Y'all did client side, right? What was the language in client side again?
JavaScript.
JavaScript, ON, object notation. JavaScript object notation. So, the majority of API calls in the Web 2.0 world are sending JSON back and forth, right? Now, the PHP interpreter, that's normal programming code. We can do all kinds of things with that. One of the most important applications, we can have this thing communicate with other servers. Most particularly, we can have it talk to SQL, an SQL server, right? Have you guys done database theory? How many, hands up if you've done database theory. Okay, for those of you who haven't, don't worry. There is a little bit of SQL that's required in this course, but there's a primer for it in the course, and also we're not going to be doing anything terribly complicated. We're basically going to stick to your basic CRUD operations, right? So you'll have to, like, you know, update, select, delete, those types of operations, right? Mostly just select, in fact. Insert, that's the other one. Most of it is select and insert. You won't really have to do much of the other ones. But you will have to do a bit of SQL here. So, a database. There's all kinds of interesting things you can do with a database. A database might be, I don't know, bank transactions, right? It might be all of the products in the Home Depot product catalog, right? Not that I do a lot of shopping at Home Depot or anything. So, because we've placed a programming language interpreter in the way of accessing our files, we can get those programs to do stuff. Does that make sense? Very good. Sort of? Yeah? Sort of? So, right. You guys want to, like, try some actual honest-to-goodness PHP? Want to start programming? You guys are programmers. You like programming, right?
Yes.
Okay, good. So, there's a... Excuse me, ma'am. There we go. Sometimes my enthusiasm gets away with me. That should be a good for an out-of-context clip. The professor hits himself with projection screen .mp4. So there's a program that we use to emulate the server, which is CS Unix. It's called XAMPP. I'll show you how to use it. We also have the CS Unix server itself. Deploying things to CS Unix works very similarly to how it worked in client side. you take your files, you copy them over, and you're done. Well, no, you're not done. You take your files, you copy them over, and you test them. Particularly important in the case of server programming is that you test your program on the live server. Because if I come to it and I test it, and it's junk, your mark's going to be junk, right? Regardless of how well it ran on your own little computer, it doesn't matter how well it runs on your own computer. What matters is how well does it run on the server. Perfect example of this. A lot of the time on the database assignment, which is the last one, people work it out on their own little computer. They do just fine. There are a few steps you have to do to get it hooked up to the SQL server on CS Unix. People will sometimes just not do that, and so their submission can't access the database, can't load any data, and is therefore garbage. And their mark is also garbage. For now, we're going to be using the emulated server environment. This is called XAMPP. XAMPP. If you have your own personal devices, I highly recommend installing XAMPP on your own personal device so that you can work on your assignments outside of the labs, but you can get it in lab. It's available through apps anywhere. So log into Apps Anywhere, please. There we go. That's XAMPP with 2 P's. What? Oh, pardon me, sir. Is it not in there? Did they take it out? Oh, I'm going to have words with people if this is the case. Would be lovely if things stayed where you put them, okay? All right. We're just going to have to use CS Unix directly then. Follow along, try to keep up. Launch PuTTY. An IT ticket is being submitted this very afternoon. I shall have strong words for them. Yeah, it's not. So, you will be presented with the PuTTY configuration. You probably, some of you may not have used this since you initially set your passwords way back in HTML and CSS. For everyone's convenience, I shall increase the font. Is this clearly readable from you folks in the back row? Or I can increase the font.
Please increase a little bit.
Is that good?
Yeah, that's better.
So host name is CS Unix, sunix.mopacollege.ca. your username will be SA followed by your student number, and your password, hopefully you remember. If you don't, I can reset it for you. Okay? But it's the same password you use for WinSCP. Okay? Everyone here has used CS Unix before, right? Anybody know? Good. All right. There we go. So this is a bash prompt. Another important thing to know, has that me turning that switch actually affected the air? Feels maybe it's a little cooler in here. No? Hasn't changed at all? Yeah. Well, if that's the case, I'm going to turn it off because the thing's loud. So, an important thing to know. The overwhelming majority of servers currently in use are based on Linux. Not even Unix, Linux. Linux is an operating system. Apache, this is an Apache server. Apache is a variant of Linux. This thing that you see before you is the bash prompt. This $ symbol right here, that is the bash prompt. You enter bash commands at the bash prompt. This is a command line based operating system, right? It doesn't have a nice GUI where you can launch programs from a start icon. You have to know the program names and type them and press enter, and that's how you run programs. There are many programs, and many of them are very simple. We'll need to know a few basic ones just to get started. So, here we go. Does everybody have this open, by the way? Anybody not have this open? If you don't have this open, you can't participate in the class. Okay. So, your first command is ls. ls lists the contents of the current working directory. Since we just logged in, the current working directory is your home directory. This is also the one that you're by default brought to by WinSCP. Tilde means home. So we are home. Within the way that Apache server user accounts work, anything that goes in the public HTML directory, directories are in blue, all of that is publicly facing internet, right? This is on the internet if it is in that folder. So, now for our next command. CD. CD stands for change directory. You then type the name of the directory. Oh, whoa, am I a wizard? How did I get the whole directory name from just one character? It was using the tab button. In Bash, tab is autocomplete. It will autocomplete file and folder names very conveniently, so long as what you're trying to autocomplete sort of resolves to one unique name. If it resolves to more than one, then you'll have to if you hit tab a couple of times, it'll tell you what your options are, and you can type a few more characters, hit tab again. Another very useful thing to know is that you can use up and down arrows to scroll through your list of previously entered commands. This is extremely convenient. So, ls, you can see this is the list of my, this is currently what's in my folder. So, if everybody could cd into public HTML, that'd be great. The next thing that we need to do, we need to create a new directory for the work we're doing today. So, mkdir, make directory. You then choose the name of the directory. You can see I have a bit of a naming convention going on, so I'm going to call this Summer 2026, because that's what this is. You can see that after entering make directory Summer 2026, I now have a Summer 2026 directory. Entering it is a separate operation. cd Summer 2026. You can see the directory that we are currently occupying is Summer 2026. Make sense? So far so good? Did everybody get that far? Does anybody need a hand? I can come and take a look if anybody's experiencing problems. All right, moving right along then. So, I'm going to make another directory for today's work. All right, so let's call this 2026, or I'll just give it, that's already, that's in 05-04, 05-04. So, one thing that's very, very important with Linux, don't put spaces in the names of things. All right? If you want a space character, use underscore or use hyphen, because space is what separates arguments, so it can't also be included in your file name without extra characters, which is just a pain. Just use hyphen. Okay? So, then cd into the new folder. We have an empty folder. Very good. We're ready to start working on files now. So, just for the time being, just to demonstrate how this works, let's make a little tiny HTML file that says basically nothing. All right? Your basic text editor is a program called Nano. You type Nano, and then the name of the file you want to edit. For example, let's not do index, let's do page.html. I really like Nano because it gives you this bar along the bottom that tells you what all of your shortcuts are for saving and quitting and all of those operations. So, let's drop in just the eensy-weensiest bit of HTML. Let's just say it's not HTML5 compliant, but it should still load. So, the command to save is Control-S. The command to exit is Control-X. The little caret symbol means control. Control X, and we're back here. Now, you can take a web browser, and you can navigate to the page we just made. csunix.mohawkcollege.ca/tilde, then your username. Your username. In my case, it's Moore, because that's my username. I am a professor, and therefore not an SA. Did you know what SA stands for?
Student account?
That's right. Not being a student, I don't have a student account. So, /S2026/040504, enter. So this is the page that an Apache server gives you if there's no index page. You can select files by clicking on them, and oh look! There's our HTML. It's on the live server. Sound good? All right. So, now, we're ready to start doing some PHP. Dun, da, da, dun, da, da, dun, dun, da, da, da. So, nano hello.php. In order for a file to have embedded PHP code that you execute, the file extension must be .php. That's a hard requirement. There we go, hello.php. Now, PHP is a funny little girl. The original intention of the language was to modify HTML documents, right? PHP, personal homepage. Overall, this document is still an HTML document. But it's an HTML document which can contain PHP scripts. This means that we need to use explicit characters to turn PHP mode on and off. The tag to start PHP is this. Get used to this one because you'll be using it a lot in this class. Open PHP tag. To close, question mark, closing angle brace. Everything within these is PHP code. Everything outside is HTML. Okay? So, for example, something like that. Now, in contrast to most of the other languages you've used, PHP means something very specific when it prints something, right? When PHP prints, it prints into the context of the file containing the script. What does that mean? It means anything that this script, this block of code, prints is substituted for the code itself in the file before it's sent out to the client. So, if I have this script output hello world, I will get H3 baby's first PHP hello world. We'll see how it works. But first I've got another fun little quiz for you. How do you print stuff in Python? What's the command?
Print.
Print, yes. How about Java?
System.out.print.
System.out.println, yes. What about JavaScript?
Console.log.
Console.log. Anybody care to guess what it is in PHP? Don't look it up.
Markdown.
Nope. You're gonna love it. It's Echo. Echo. Why? Why is it Echo? That's because that's also what it is in Bash. First lesson about PHP. PHP thinks that it's Bash, but it isn't. So, save. Let's reload. Let's go back. Reload the page. You'll see that hello.php now appears in our list of files. If we select it, hello world indeed. Now, this is not quite HTML compliant. You can see we have text here that's not inside of a paragraph. Oh no. You'll find when you're using PHP, like, we kind of skip a lot of the usual niceties of HTML in class for the sake of brevity, but you know, when you're doing an assignment, I'll expect you to be doing HTML5 compliant. Okay? So, okay, there are no tags. What if we put one in? And there you go. So, when you're using PHP to sort of splice together an HTML file, it's very, very useful to have the Elements tab open so that you can see what's happening to the raw text of the HTML. That's very useful. Okay? Make sense? Good. So, did everybody get that working?
Nope.
Got a problem?
Yep.
Let me take a look.
So I think we're still in the XML also trying to get to
Oh, yes, okay.
So he is right with the PHP file and stuff is like this now.
Save it for sure. Alright. Ah, you're still on the old page. So, just hit back. Oh, forward, or here. If I can. No. There you go. You're welcome. There you go. Good. Anybody else need a hand? All good? Okay. All right. So, this is the essence of PHP. It's like this, but you can use if statements and stuff, loops. Actually, you know, like, you won't find you use a lot of loops in PHP, actually. most of the time, like, whenever you're doing loops, you'll be doing it over data structures, and occasionally you'll do that over like a database output, but like, most of the time, we're gonna be in if statement land most of the time. So, all right. Very good. Since we're here, you guys wanna see what declaring a variable looks like? So, broadly speaking, we are more so in Python territory than Java or JavaScript territory here. You declare variables by using them. You do not have to declare what type they are. You do not even have to declare the scope using let or const or var or any of those JavaScript things. It's just, you just assign to it, and that makes the variable. But there's something here that's kind of worrisome. Anybody see the worrisome, troublesome character? $sign is necessary for all variable names in PHP. No matter where the variable is or what it's called, all variables start with a $sign. Why? Why on earth, may you ask? It's because that's how Bash does it. I told you, PHP thinks it's Bash. Semicolons are required except on the last line of a PHP script, but I encourage you to just always use semicolon everywhere anyways. Okay? So, would you like to see what PHP does when you make a minor syntax error? Like forgetting a semicolon? This is also very instructive. It dropped that into the website. What's interesting here is not necessarily the error itself, except to, that doesn't exactly say missing semicolon, does it? Right? This is what you have to work with in terms of error messages. But what's more interesting is where the error has popped up. Because it has pushed its way all the way through to the front of the web page. It's been integrated into the text of the HTML, my friends. That's where the error has popped up. So, do you guys know about the network tab? I'll give you a quick intro to the network tab if you haven't seen it before. So, because what we're doing in this class is client-server communication, the network tab is going to be very important, right? This is where you see what the client has sent to the server and what the server sent back in terms of raw text. This is probably your number one debugging tool. This is where you should be looking first. Okay? So, it keeps a register of every packet that's been sent from the client to the server, and whether or not it was responded to and in what manner. So, if we take a look at hello.php, notice our status code is 200, meaning okay. Is this okay? Did we get an error? Yes. So why are you telling me that things are okay, PHP? some types of errors will produce weird error codes. But not all of them, which is annoying. So if you take a look at the response, preview is the response parsed as HTML. If you take a look at the raw text of the response, there you go. You can view your error. The problem that you'll find is, if you've made this kind of a minor syntax error, and the thing you're expecting back is JSON and not HTML, the client will attempt to parse the returned packet as JSON. If it includes that, it won't parse. So it is very important that you can manually check what the exact text that the server sent you is. Does that make sense? A good deal of the difficulty, at least in this half of the course, is just getting everything hooked up and talking to itself. Getting the server talking to the client and the client talking to the server correctly is a non-trivial hurdle, and if you don't overcome this hurdle, it's required for the whole rest of the course. So, you've got to get the client talking to the server. Make sense? Good. In this class, I like to do a lot of live code examples because I myself make mistakes occasionally, believe it or not. When I make a mistake in class, that's probably the part where you should be paying attention most closely, because you'll get to watch me debug it live, and you get to see the techniques I use to debug the code in class, right? So, now, unfortunately, for whatever reason, XAMPP is offline today. Hopefully it'll be up by Wednesday. Nano is really only doing syntax highlighting. It's not even doing any form of autocomplete. Normally, you'll be coding in VS Code, which will do things like highlight where you've forgotten a semicolon, right? But, I kind of think it's good practice to use a lower down text editor like this because, especially if you're studying for the test, for example, this thing gives you a lot less help, which means that it's your knowledge that will shine through, right? So, any questions so far? Good. Well, that's Hello World. So, since we're here, let's take a little look-see and poke around inside of these requests and see what some of the values we're going to be working with are. So, often they put the important stuff at the top, right? The URL, the request URL itself, is obviously one of the most important pieces of information in there. That tells us where the packet is heading. Request method get. Do you guys remember the difference between get and post from client side? Anybody care to share with the class? What's the difference between get and post?
Get means you're asking for something to receive something, while post is you're placing something somewhere.
Right. The word post has even bled through into the sort of general internet slang or lexicon, right? Like when you put an image up on Instagram, you are making a post, right? Post in this sense. It's because the request method is post. Now, You may also recall there was something in the client-side course about GET requests are less secure, POST requests are more secure because POST requests put the data encrypted in the payload. By the way, that's the payload, right? Whereas the GET request encodes it in the URL, that's less secure, right? This is actually kind of wrong and false. You can put information in the body of a GET request. You can attach URL parameters to a POST request. The only thing that changes when you change from GET to POST are these characters, this field, right? Everything else is interpretation by the server. The server interprets GET requests in a certain way. It interprets POST requests in a certain way. It's not that there's any hard restriction that a POST request must send data to the server. That's a convention. There's nothing in code that makes that so, unless the coder makes it so. Does that make sense? So if you want, you can write your server in such a way that, I receive parameters by, I receive URL stuff by POST, and I receive stuff for the database by GET. That's just the way I roll. And it's like, yeah, it technically works, but no other programmer or anybody who uses your API or website is going to know what's going on. So you should do what everyone else does. And that's the only thing. That's the only thing requiring a person to use GET and POST in those particular those manners is the sort of the force of peer pressure. Yes?
So it's basically just words.
The whole thing is just words. Right? Yeah. Which, it's kind of a complicated way of saying, words themselves don't really have meaning. We're the ones who give words meaning, right? Which is kind of true in a general sense, right? But yeah, these are just words. We give them meaning, right? But yeah, so that's the request method. We're going to be dealing with a few additional request methods later on when we start to talk about APIs. You'll talk about those with Jonathan, but for now, GET and POST are where we're going to live. Status code. Status code is how the server tells the client how the request went. The best way to show you what all of these different things are and do is using the following website. HTTP-cats. This is a website where each of the internet return codes corresponds to a different cat photo. So for example, processing, transformation applied, but perhaps we do a more interesting one. 401 unauthorized, 404 not found. Everybody's favorite, I'm a teapot. The server refuses to brew coffee in a teapot. This is one that you'll probably get a fair amount. Internal server error. This is basically a catch-all that PHP servers will often use if there's some kind of catastrophic error. We saw that a simple forgotten semicolon is not going to bork it at this level. But if you have a more substantial server error, error 500 is the one that you should expect to see. I think failure to parse JSON is in that category, stuff like that. But yeah, so this is what status code means. Not extended. The web server is down. There you go. So, that's what status code means. There are a few other important ones. Content type is fairly important. So you remember me saying that the server could be sending back HTML, it could be sending JSON, it could be sending a lot of different things, right? It could be even sending images, right? The content type tells us what the content type is. What is the type of data I'm receiving? This generally maps to file extensions. These are called MIME types. No, what? Stop. Google, I just want, there you go. By the way, if you can stand to read it, MDN is extremely good and complete reference. It's the Mozilla Developers Network, I think it's what it is. So, MIME types, right? Where's the list? Media types. No. Where is it here? Oh, there's like a table somewhere here. Yeah, there you go. That's what I'm looking for. So if you look up the file extension for the particular type of data you're trying to send, this string is what you would expect to see in the content type of the header. Make sense? It's important to set that, because otherwise the client or the server doesn't know what kind of information is being passed back and forth. So, let's see here. There's a lot of other stuff that we don't really have to worry about. Like, what is my operating system? What is like what's the browser? What's the browser version? You know, all kinds of stuff. So, okay. So why do we need all of this PHP business? Like, we already know some JavaScript, right? Surely we can do dynamic content using JavaScript, right? Well, it really kind of depends. The way things have moved in recent years is more into the realm of the API, which means you basically load a somewhat basic website that doesn't have the data, right? You then look the data up using additional requests. But even that basic page is going to need some content relating to what needs to be looked up, right? So, for example, let's consider, I don't know, Amazon, right? If I were to pull up Amazon, right? We can actually see how much API traffic is going on, right? If you go to your network tab, right? You can see what they've gotten. and you can even see what type it is. You can see that most of the after initial load stuff that they've loaded is GIF. A little bit is text HTML. You can even look and see what that is. Empty stuff mostly, it seems. But the initial, like the products that are on the initial page initially, those are not static, right? These will change day by day, hour by hour, depending on what promotions there are on offer, depending on, what people in the same IP range as you have been looking up, stuff like that. So, for some reason, they think that I need diapers, jewelry, and perfume, so they really don't know very much about me. Only one of those three things is true, and not for the reason that you might suppose. That's just a little joke. I have small children at home who require diapers. That's the one. I'm not trying to catch fish with shiny jewelry or anything. This is dynamic content, but it's not been loaded dynamically, right? It came with the initial page. So, a script put it there. A script put it there on the server before we loaded it, right? Always and everywhere, there are trade-offs, right? In computing, a lot of the time, the trade-off that we're working with is runtime versus memory consumption, right? You can decrease runtime by spending memory. This is called caching, right? In web world, there are a whole different set of trade-offs, right? Do I have dynamic processing on the client or on the server? Well, if I do it on the client, I don't have to pay for it. That's good. If I do it on the server, I can do it in a secured environment. That's good. The more AJAX you do, the more bandwidth you're consuming, right? The more packets there are being fired back and forth, the more you, if your network infrastructure can only accommodate so many packets before you have to upgrade it. Upgrading things costs money, right? So, everything is a trade-off. You try to do things as efficiently as possible in the sort of way that makes sense for the application. The reason it's a trade-off is because every application that you develop will have different requirements. It will require a different balance of the trade-offs, right? So, you have to be flexible enough to know what the trade-offs are and pick them out appropriately. Make sense? Any questions? Let's take a look. So, we'll talk about this one when I can actually show you XAMPP, which will be hopefully on Wednesday. So, let's talk a little bit about how websites are developed. So, in this diploma, we are training you to become full stack developers. Full stack developers. Full stack developers can do both front end and back end. Client side was front end. This correspondingly is back end. When when you go up to somebody who actually works in the industry and knows 10,000 million times more than you do, and I include myself when I say that, the very next question they'll ask you, once you say, oh yeah, I did full stack development at Mohawk College, and they'll say, great, what stack did you learn? Right? So you have to know what a stack is. A stack is most often an acronym. Yay, acronyms! So, it's an acronym that tells you which of the particular technologies you're using for this particular application. So, because a lot of them can be sort of swapped out and mixed and matched. The one that we are learning right now is called LAMP. The LAMP stack. This is Linux, Apache, MySQL / MariaDB. They both kind of work the same. And PHP. Right? But, interesting thing about servers. Any language can be used to create a server. You got Java servers. You've got Python servers, Django and Flask. You've got JavaScript servers, Node.js, right? This guy can be swapped out. The particular type of database you're using can be swapped out. You want to use Mongo, a non-SQL database? Sure, swap that out, right? Linux and Apache, those are kind of more tightly coupled. Although Apache, there are other types of server operating systems that are not Linux that you can use, such as Nginx, which is a fairly popular one these days, right? So that's the stack that we are currently learning. There's another one which you might hear, which is the MERN stack, right? MERN, like the M might be like MySQL, might also be Mongo. That's your database, right? E is Express. Express is a framework for Node.js, and React is the front-end framework, right? So back-end framework, front-end framework, like the server programming language and the type of database you're using. MERN stack is another one, right? Here's another one for you. TTT, all right? And no, it isn't Trouble in Terrorist Town, which I think is that's the Gary's Mod one, right? Yeah, no, it's TypeScript, and you guessed it, TypeScript. TypeScript. Because all of these are JavaScript. You can do anything in JavaScript in TypeScript, so it's basically just TypeScript. Right? This one's actually gaining popularity because JavaScript is awful and TypeScript is better. Although still awful because it's based on JavaScript and JavaScript is awful. But you know, TypeScript seeks to address some of the problems with it. So, of these, some of these are front end, some of these are back end. In theory, what you should be doing, like, if you work for a small company, it's very likely you'll be responsible for the whole stack, right? And that's not necessarily a bad position to be in, right? It's not necessarily a bad position to be the one web developer because you're kind of essential, right? Not a bad place to be in a company. If you're in a larger company, right, one of the first things that they divide labor along is front end, back end, right? So effectively, much of the time you'll be either a front end or a back end person, but knowledge of the other half is substantially helpful. Even if you end up being a back end person most of the time, knowing how front end works really helps you be a back end person. Same the other way around, right? Make sense? If you have no particular artistic skill, but you're a good programmer, I would recommend back end. If you're, if you have a flair for design, shall we say, then you'll probably find front end to be a bit more comfortable, right? But mostly, the most important thing is, who will give me a job? I will do what they want me to do, right? All right, thank you very much everybody for your time and attention today. We will resume on Wednesday at 3 p.m. I'll see if I can get XAMPP working by then. All right. One of the things that we're actually going to discuss over the course of this course is the exact mechanism by which a phishing email works. So look forward to that. We're not quite there yet though. So I was promised by IAT that we would have XAMPP working today. So let's take a look. That's not my password. That's my password. Let's see here. XAMPP is back! Yay! Alright. If everybody could please, if you're not logged into the lab computer, please log into the lab computer. Unless you were proactive and you went ahead and installed XAMPP on your own machine. If you didn't, this will be faster. So just, log yourself in. There you go. We will be looking for XAMPP in Apps Anywhere. So it's important to explain what XAMPP even is. So it is a server emulation, it's server emulation software. When you're developing applications, let me just make sure this is recording. Is it recording? Did I forget to hit the button? It is recording. Okay, good. When you are developing applications which are intended to be published on the actual internet, you want a testing environment that is separate from your deployment, right? Your deployment environment. For us, in this course, our deployment environment will be, can anybody guess?
CS Unix.
CS Unix is correct. CS Unix is a publicly, outward-facing Apache web server. This we will consider our production or deployment vehicle. Now, a thing that you shouldn't do, you should not be doing development work on something that's publicly facing. What if a user logs in and finds your buggy, half-completed website that's taken you several months to work out the kinks, right? It's a bad user experience to see a half-finished website, right? So, what you do is you have your deployment version that's stable, you keep that the same while you're working on your updates or improvements or what have you, right? Within the context of a Git repository, the main branch serves this same function. You're supposed to do any of your new features or add-ons or anything, bug fixes, in branches and then merge those back in once complete. This is the height of good manners. So, XAMPP, please launch, is our testing environment for Apache servers. It's the one that we are using here. All right, there are certainly other ways to do this, but this is what we got for the moment for this course. So, take a look. This is the XAMPP control panel. Ooh, wow. Each of these options, listed as services, service modules, each of these is an individual server process. Each of these specific server instances, they can be turned on and off separately, and they all listen for incoming packets of different types. Apache is a web server. Its purpose is serving HTTP or HTTPS packets, regular web packets. When, in client side, you wrote AJAX requests, the AJAX requests are HTTP requests. So they are served by a web server, in our case Apache. MySQL, anybody care to guess what that guy is? I think, did I take a poll on Monday to see if anybody had taken the database course? And like a couple of you have, right? So MySQL is the database server. The database server services SQL packets rather than HTTP packets. It's a different packet format. We can launch this independently of our web server. This is something that we will, I will be gone, but after the mid-semester handoff, you'll be getting into databases, how to hook a web server up to make requests to an SQL database, and that is a very, very good and important thing to know, especially in the modern internet. For those of you who have taken the database course, you may have been sitting down in front of all of these queries and this, table normalization and all of this stuff, and you're like, who uses this? I've never seen this before. What's this even good for? It's mostly for other computers to talk to these days. It still happens, but overwhelmingly the majority of requests that are served by SQL servers are not written by humans, right? They're composed by things like web applications, right? So part of what we want to do here is to teach you how to create web applications that can talk to servers. That's part of what we're doing here. Does that make sense? Does that sound just a little bit exciting? No? Nothing involving a database sounds exciting, right? Yes?
When you said most of these SQL queries are made by web apps, are you talking about when you give what's it called? Dynamic? You tell applications to make CRUD commands when you create an account or stuff like that, or get an account into this post or something.
Yes. So here are some examples. Let's take random social media website like Facebook, right? You post things to Facebook, right? Facebook keeps all of their posts in a database. You're not writing an SQL query when you post something on Facebook. You're filling in like a little text box, attach an image, hit post, right? Something like that, maybe a little more complicated than that. That information is sent from the client. You are interfacing with the client, right? It's sent from the client to the server. The server composes the SQL query, sends that to the database server. Database server stores the post, right? Consider getting your feed of posts on Facebook, right? Your client requests the information in the feed, sends that request to the server. The server composes an SQL statement requesting the specific information that you would be in your feed, right? Now, that's a kind of a complicated thing at the moment, right? In general, what social media is a view of posts made by people, filtered for the people you're following, plus whatever they're doing with recommendations, right? So, whatever that algorithm is, the end result is you get a big dump of JSON-contained posts, right? That big dump of JSON is actually composed by the server, right? It's going to come from the database as SQL output. It has its own particular format. So it comes from the database as SQL result or output. The server formats that into JSON, sends it to the client. Client catches the JSON, makes it into divs and buttons and all of it. Displays the images and all of that front-end stuff. Does that make sense? It's actually quite dangerous. You would never, forever, never want to allow an end user to give you SQL code directly, right? Because you're trusting them with your life, right? If an end user had the ability to write arbitrary SQL queries and send them to the database, they could very easily do things that were malicious or damaging, right? So part of the purpose of the server is acting as middleware, right? Protecting the database from harmful inputs from end users, right? But still allowing enough access that the program works, right? That's called, but of course, hackers are very clever and they're always looking for ways, right? What they're attempting to do is what's called an SQL injection attack, right? Anybody heard of an SQL injection attack? Yeah. Can you give us a definition? No? So it's a code injection attack. Code injection attacks are a category of attack. We'll be discussing, cross-site scripting attacks are also code injection attacks. But the whole point is you're trying to get your code, which is stinky and bad, to execute on someone's nice clean server, right? So if you're trying to get code injected, right? You want them to run your code, right? Not their own code. There are many different ways you can do this. We're going to, throughout the course, look at some, mechanisms for protecting yourself from this. A lot of code injection attacks sort of hinge on putting special characters in inputs that allow you to break into programming mode. But yeah. Does that make sense?
Yeah.
Follow-up question?
Is that why there's some input fields that say this certain character is not allowed when you're trying to create a name or whatever? They say this input field is not allowed. Only use letters, numbers, and periods or something.
Yeah, that's yes, absolutely. Anything on a web form generally can be an attack point, right? So yes, the username on a login could be if the server hasn't been protected. Even what is your username box? You can dump some SQL code in there, try to get it to run on the database server, and you can do lots of nasty things. Oh, steal 4 terabytes worth of student data off of Canvas, that sort of thing, right? So yeah, does that make sense?
Yeah.
Cool. So yes, so for us, right here, right now, we are primarily concerned with Apache and database servers. An interesting one is FileZilla. That is a file transfer protocol server, FTP server. Anybody a Mac user in here? No? Any? Yes. So FileZilla was likely what you were told to use instead of WinSCP, right? No? Okay. Well, that's one of your options. FileZilla is something that you can download for, like, it's the popular choice for Mac and Linux to perform the SCP operations required to put stuff up on CS Unix. You can run one out of here, but we're not going to do that. We don't really cover FTP servers here. We're mostly concerned with web servers and database servers. But okay, all right, sounds good. Let's fire one up, shall we? To start your Apache web server, click the Start button. There you go. Green means go. Very good. It gives you some numbers. Process ID numbers. These are important if you need to kill it. You need to know what the process ID is. Port numbers are a bit more important. So, we can access our Apache server from any web browser. I use Chrome, but whatever one you want. Localhost, 1080. Notice, 1080 is specified as one of the port numbers here. So the port numbers, the first one is outgoing, the second one is incoming. So I'll explain what a port is reasonably quickly. I just want to show you what happens when you press enter. XAMPP. This is basically the splash page for the XAMPP server. Make sense? This is its default page. If you can see this, you're doing well. So let's talk about what a port number is and all of that nonsense. Yes?
Mine worked without entering the port number, but entering the port number doesn't work.
Oh, is yours being configured to run different ports?
I don't know. It's different ports. 8443. It's a higher version.
Oh, yes. So port 80 is the, okay, we have to be careful about using higher versions. That's a separate conversation. But port 80 is it's the default port for localhost. So it's not surprising that it's been configured for port 80 here. For whatever reason on the school systems, it chooses 1080. I don't know why. But let us discuss what a port even is. All right? So, you will have seen this diagram before. We have client and we have server. Right? Communication goes from client to server. That is a request packet. This is a response packet. Right? So far, so good. We need to dig a little bit. This is too abstract a view. We need more detail to understand, to be able to program servers. So, understand that clients and servers are software processes, not hardware. Right? This is a very important first distinction. What is the thing running on the client computer, which is actually making the request. In the case of what we just did, what is the piece of software that made the web request? When we typed localhost 1080, where did we type it?
Search bar,
In the search bar of
that web application like Google.
the web application. In my case, I used Chrome, right? So the browser, right? So the web browser is the client application, right? So when we make a request, a normal request, that request must first pass through a portion of the computer called the socket layer. So, does anybody here live in an apartment building? Yeah? Normally on the ground floor, at least in a couple of apartment buildings I've seen, you have this wall or board, depending on how big it is, which is all of the mail slots, right? And you have a whole bunch of little doors with, you got your key for your mail slot, you put it in, you open your little door, you get out your bills, you put it back, you lock it, right? On the other side, right, it's often just open. This is particularly true in like post offices, right? If you're in a region where you have those little standalone post box things, it's kind of a similar system, right? The postman goes around to the back of it, unlocks it, puts the letters in each of the slots, locks it back up again, and goes to the next one, right? This is how the socket layer works, right? The socket layer is a big post box system, but instead of letters, they're packets, right? Request packets and response packets. So, when the browser creates a request packet, it sends that packet to a pre-configured spot in the socket layer, right? I'm not sure if this is correct, but let's pick a number, 443, right? Or actually, you know what? I'm going to pick a different number, which is probably, since I'm not sure that's correct, I'll use a different number. Let's say port number 100, right? So, the question is now that we have stuck the letter into the post box, we need a process to come along looking for letters in the post box, right? So, if this is outbound network communication, right? You then have, you have this kind of wibbly-wobbly cloud in the middle called network infrastructure. Spelling. There we go. The network's monitoring the slot. If anything pops in, it grabs it and it sends it out to all of the routers and switches and Wi-Fi and blah-de-blah-de-blah that we don't have to care about because we're not in the networking stream, right? Basically, the division of labor between us and the networking guys, kind of like, depending on how you count it, it might fall along here, it might fall along there in certain circumstances, right? Generally, you as software developers are probably happier the closer this is to your actual program. The less networking stuff you have to worry about, the more life satisfaction you will have, right? But the network infrastructure is watching for packets being stuffed into sockets. When it happens, it pulls it out, throws it into the internet, and it eventually, it pops up again. It eventually pushes it into the socket layer of the server machine, right? Now the server machine, again, has a software process running on it, right? Which is the actual server. In our case, it's going to be an Apache web server, right? So, let's say that our little packet, a request for funnymeme.jpg, right? It gets pushed into some random port, let's say 200. The Apache web server is listening for a particular port number. It's monitoring a particular port. So, when something arrives in port 200, it goes in with its key, unlocks the little cubby, pulls out the HTTP packet, opens it up, says, a request for funnymeme.jpg. I've got that in my hard drive somewhere. Tapes up this Canada Post cardboard box mail thing and, puts it in its outgoing port. Right? So it sends its response into the outgoing port. The network is, of course, listening for this thing, right? Out the packet goes, back into the network infrastructure. It comes into a different port over here, which the browser is configured to listen for the response on, right? So it's listening for responses. It's like, going in periodically, opening the thing, checking. Oh, my package is here. And so it grabs its package, it unpacks it for you into HTML very nicely, and you get to see your funny meme. Right? And that's how the internet works. Now, that's how things normally work when the browser is looking for an external connection, right? What we just did with XAMPP is a slightly different kettle of fish, all right? In our case, the server software and the client software reside on the same machine. So, in fact, XAMPP is located within the client. Does that make sense? Yeah, I mean, it should. It's a program running on this computer. The web browser is a program running on this computer, right? So, when we launched our XAMPP program, we saw that the port numbers it gave us, 1080 for incoming requests, 443 for outgoing, right? So, when the browser accesses http://localhost:1080, localhost, which by the way is that's actually an alias for the following IP address, 127.0.0.1, which means myself, right? This means me, right? I'm saying to this IP address at this port, send a request packet, right? So that's what the browser does. It sends a new request packet, places it in 1080. Now, because it's been given this very specific thing, which means redirect that to myself, don't put it out to the network, it means that things on this side of socket layer can check that mailbox, right? So XAMPP reads, opens the cubby, reads, gets the HTTP request packet, right? But from the perspective of the web server, it doesn't really matter to it how that packet got into that socket, right? So, for example, to bring us back to the mailbox, right? When you check your mailbox for your mail, do you know anything about the postal worker who put it there? No. You don't know whether, their hair is blue or green or black or yellow. You don't know whether they enjoy long walks on the beach on the weekends. You know nothing about them. Probably I would expect a postal worker wouldn't need to enjoy long walks on weekends because that's a job that already involves quite a lot of walking. So you're walking recreationally too? Just seems a little strange. You don't know anything about the process that put the packet there. It could have come from inside. It could have come from outside. It doesn't matter. All you see is a packet in a slot. So it takes that packet, it processes it, and it puts its output in the output port, which the browser is monitoring, it gets the response packet, integrates it into itself. Again, from the browser's perspective, it doesn't matter if a local instance of the server put that thing there or an external version put that there. It doesn't matter to the browser. All the browser's doing is reading a packet, right? So, that's how we can emulate a server running on our own machine, and yet it will behave exactly like if we took the exact same code and put it up on a remote server. It's because the socket layer is doing all of this work for us. Does that make sense? Are there any questions about that? Cool. So yeah, if you ever see a colon with a number after it in the domain of a URL, that's a port number. All right? Anybody ever try to access your router using HTTP? This is a thing you can do. If you get the IP address of your router, which is sometimes like printed on the underside of the router, you can access your router by just going to your URL address bar and entering the IP address for your router. And that's about as much networking as we're going to do. But yeah, so, all right. So that's a lot of information. Let's see how we can use the thing to do some bloody PHP, shall we? So, as we saw on Monday, on CS Unix, we have a directory where we put files, and those files go on the internet. We need a similar mechanism here. Now, this is not Linux, this is Windows. We are working in a Windows file system. Certain things are going to be true, certain things are going to be false. Linux is better. if you click the Explorer button right here, it brings you to the installation directory of XAMPP. There's a lot of stuff here that we don't have to worry about. There is one thing in particular that we do. The folder htdocs is the same as your public HTML folder on CS Unix. That is where the stuff goes. So, for example, if I create a new folder, maybe call it 2026-05-06, just for example, maybe I create a new text document. Oh, wait, whoa, this is Windows. So, Windows does an extremely frustrating thing. It, by default, hides your file extensions from you. This is information you should have. You must click View, File, Name, Extensions. If it's your own Windows machine, I recommend going into the user settings and setting that permanently. It's not possible on the lab computers, though. You have to go into View every time. So, let's rename this. Hello.txt. Hello, world. The default configuration of an Apache server is that it is a file server. So let's see if we can serve this file. Accessing 2026-05-06, which is the directory that I created. This should be familiar from last class. This is our Apache server content view, file system view. It's what we get when there's no index page. Right? There is no index page, only humble hello.txt. Clicking on it, you can see hello world is what we get. Very good. You can serve HTML in basically the same way as you do on CS Unix. Make sense? This also means we can write PHP scripts this way. So, I'm just going to do this in Notepad because that's what I feel like doing at the moment. Hello.php.
If you change the file name extension, the file might become unusable. Are you sure you want to change it?
Yes. It's like, yes, Windows. And incidentally, that's a lie because all you have to do is change it back and it's fine. As long as you don't open it with a program that corrupts it. Most programs, when they encounter a file type they're not designed for, won't then destroy the file. They'll just not read it. PHP opening tag, PHP closing tag, echo, hello world. There we go. On our Apache web server, you can see we now have hello.php as well. Click that, hello world, ba-boom. So it goes. We now have PHP working on XAMPP. Sound good? Any questions? All right, now I'm going to talk about like boring version stuff. and the programming IDE and other things which, you know, seem like they're trivial but are actually really strongly not trivial. So, CS Unix is your deployment platform, right? In order for the testing environment to stand you in good stead, it should have the same versions of things as the deployment environment. This stands to reason, right? We can actually we can test to see what the version of PHP is on the server. We just have to quickly open up PuTTY. You don't have to do this. I'm just going to show you something quick. PuTTY. Appearance. Let's give it a little bit more. That'll probably be fine. Sessions. Unix. College.ca. Alright, so generally speaking, to check the versions of programs, -v is what you use. This is called a flag, right? You pass the V flag to check the version. So, you can tell, not only, like, what the version is. The version of PHP on the server is 7.2.24. You can also see when the last time IT built the server was. That's like 7 years ago. This is a bad thing. That's not good. That means that the CS Unix server is missing about 7 years worth of security updates. But it doesn't matter because it's for children. You're all children in this example. So, you're not actually children, you're adults. You know what I mean. Students don't count, that's why you get crappy hardware, right? So, it's important that your version of XAMPP be configured with this particular version of PHP, because this is the platform I'm going to be testing your work on to see if it works, right? So it has to work for this version. This means you have to download a specific version of XAMPP if you're going to install it on your own computer. All the best software is on SourceForge. There's XAMPP for you. You go to, where is it here? User ratings. Yay, it's great. No, it's terrible. Where is it? Files? Yes, here we go. So you choose the version for your operating system. Perhaps it's Windows. You see that you have a whole bunch of version-coded versions of XAMPP. These actually are the PHP versions. So, if you simply Control F, 7.2.24, you arrive at the specific version of XAMPP which is being run on CS Unix, and that is the one you get. Okay? Make sense? If you're going to install this on your own computer, which I highly recommend because it's convenient to be able to do your homework on your own computer, right? So, any questions about that? This does actually matter. At least a few times a semester, I have to throw someone's assignment back at them and say, listen, this doesn't actually work on CS Unix. And invariably, it's some syntax construct that, like, their editor has suggested or something, or God forbid the AI has suggested, which is like, you know, it's like syntax that was introduced in like 8.1.3 or something like that, so CS Unix doesn't support it, just doesn't support it, thinks it's a syntax error. This happens at least a few times a semester. So I'm hoping it won't this time, because here you all are, and hopefully if you're not here, you listen to the video and heed my warning. Here's another thing that the AI is really not very good at, is like, hey, could you give me an implementation of this that's specific to PHP version 7.2.24? It's like, oh yeah, I'll do that, and then it doesn't, right? It's like, oh yes, that's a fantastic idea, user. Oh, I'm so happy you suggested that. 7.2.24 was the correct version of this back in 2016, which I'm sure is where you're doing a legacy application for. Oh, good job, user. You gave me more information. Good job. They have written a sycophant. Hey look, the AI telling me what a sycophant is. So, we do try to have fun in this class. So let me see, if there's nothing else with the week 1 material, we might continue on and start talking about actual PHP. Yeah, I think we'll be okay. All right, we can talk about actual PHP. This course, like many other courses, is designed for the first week to be a bit on the lighter side, because very often, like, the first class is like orientation or Labor Day or something. So we're a little bit ahead of schedule, which is good. We should press our advantage, because who knows? I might be sick. If you guys are sick, you get to watch a video. If I'm sick, nothing happens. That's how things work around here. So if I get sick, which is entirely probable because I have 3 small children at home, class will be canceled, and we'll use up the advantage we're now gaining for ourselves. The more I talk, the less of it we have, though, so let's continue. So what does it take to be a server? It really takes nothing more than being able to listen on a port, compose packets, and send those back on a different port. Pretty much any piece of software can do this, right? All of your favorite languages have packages to let you do this, right? So the question then becomes the question that we always have when we discuss the differences between programming languages. Why do we have so many languages? Anybody care to guess? Anybody have any theories? Why are there so many programming languages? Yeah.
Different purposes.
Different purposes. What were you going to say?
Some are faster at reading data than others.
Some are faster at reading data than others. Yes, this is true. So different purposes is generally, I'd say my preferred response. Yeah. So, by way of analogy, let's imagine that you're doing some carpentry, right? You have two pieces of wood, and it is your object to join those pieces of wood using nails, right? What is the correct tool for driving nails? Basic question. A hammer. What is an incorrect tool for driving a nail?
A wrench.
A wrench. But could you still make it work with a wrench? You know, if you had a heavy enough wrench and you hit it, you know, just correctly, if you had a lot of skill with a wrench, you could drive nails with it, right? But you should probably still use a hammer, right? You will do a lot less injury to yourself and the thing you're trying to do if you use the appropriate tool for the job, right? You know, some tools are like, you know, these, have you ever seen like these old hand cranked drills, you know? Something like that. Something else is like a modern like power tool, you know, your battery operated cordless drill, right? Both for the same purpose, but one is newer and better at its job. Although always with, you know, with limitations. The cordless drill is great, but it takes batteries, and the batteries are expensive, and if you run out of juice, you have to wait for it to charge. Hand-operated, you know, a hand-cranked drill never runs out of juice until you run out of juice, right? So let's see how a few of our different languages that we know and love or hate already, see how they sort of fall into place with servers. So Python. We love Python, right? You guys like Python? I don't know. What is the student opinion of Python? Have you not done enough of it to really have formulated an opinion? Is that closer to it? Yeah. I sometimes tell people that, like, if all you've done is like the intro programming course and you put Python on your resume, you're basically kind of lying, right? Because like you haven't really done enough Python to really consider yourself a Python person, right? Unless you've done extensive like work elsewhere. So like pretty much everybody puts Python on their resume notes. So Python, some people like Python. There's some people who are like really into Python. You've got web server frameworks like Django and Flask. These are reasonably popular. Let's see how popular they actually are, though. Oh, here we go. He's pulling out the Stack Overflow developer survey. Everybody on your Dr. Moore bingo cards, there should be a spot for this one. Here we go. We don't have this year's results yet. The survey, I think, comes out in August. I am eagerly anticipating this year's new data. So yeah, I consider this to be extremely high quality data. The people who answer this survey are the people who answer questions on Stack Overflow, who are like generally considered the experts on everything. You know, like if you have a problem, where do you go? Stack Overflow. Well, if you have a problem, where do you go? The AI. Where does the AI go? Stack Overflow. So here you go. According to professionals, most popular programming languages. Have you guys seen this before? Yeah? So JavaScript's at the top. HTML and CSS are not programming languages. SQL is also not a programming language. Python's the next one up. Then Bash, which you should learn. TypeScript, which is good JavaScript. JavaScript is bad JavaScript. C#, Java, competing neck and neck. PowerShell, which is Windows Bash. There's PHP. So, but what's interesting, web frameworks. Here we go. JavaScript, 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 JavaScript. .NET, .NET is C#. JavaScript, JavaScript. I'm not sure what Fast API is for that one. There's Flask. Hi Flask. There's Python for you. Where's Django? Is Django on here? Django. There it is. Just a little bit above Laravel and beneath WordPress. By the way, and JavaScript. Laravel and WordPress are both PHP frameworks. Do you guys know what a framework is?
More or less.
Hmm?
More or less.
More or less? Can you give me an explanation?
It's like a simple way to define it would be like an easier way to use a programming language to do more things. It's like a library of different, okay, no, not a library.
That's what we would have called it in the 90s. Yeah. It's a software package which is, it takes a lot of the sort of common constructs and does pre-built versions of them that are theoretically easier to configure, right? A lot of the stuff that you do in a web server is kind of routine stuff, right? Because we're doing things in vanilla PHP, we're going to do a lot of stuff by hand that basically any one of these frameworks would have a thing for, right? But these things, like, you can have heavyweight frameworks, you can have lightweight frameworks. They are sometimes clusters of tools rather than like a tool itself. They're like a step above the base language, right? At the moment, I'm doing a fair amount with Node and Express, and I have to say that like if you're not using Express, what's wrong with you, basically? Like it makes everything so much easier that there's really no reason not to use Express, unless you're worried about like Express being hacked and stuff. But whatever. So anyway, where were we here? Java. Java applications can be deployed on various web servers and applications. The slides claim that Java is known for its high performance and high traffic scenarios, and I would say that probably what you meant to say was C++, which is the magic language that everything is calling in the back end. But yeah, okay. So if you wanna write a bunch of Java classes for stuff, you can do it in Java. We're not going to do that though. JavaScript. At the time this was put together, Node.js was probably like, it's interesting, right? Because like Node.js kind of, okay. So this is how the life cycle of one of these frameworks or libraries happens, right? Someone like invents the idea. There's like a 5-year period where there's not a huge amount of adoption, and because the thing is very, very rapidly mutating, right? The libraries are growing, they're developing it, right? Something you write in like Node year 1, like, is going to look very, very, very different from something in Node year 3, right? So that's like the first 5 years. The next 5 years, you start to see adoption, right? Things start to solidify, things start to cool down, right? Settled patterns start emerging. And then after that initial like 10-year period, the thing's more or less stabilized, right? And it's only after that period that really like places like us can start writing courses about them. Because otherwise they're moving too fast for me to even be able to write slides, right? Yeah, anyway. And then PHP. PHP was specifically designed for web development, making it a natural choice for server-side tasks. Of all of these languages, yes, PHP is a domain-specific language for modifying HTML before it gets sent out. That's what PHP is for. PHP syntax is similar to C-style languages, making it relatively easy for developers familiar with, like, to say something is C-style syntax is to say just like nothing. Everything is C-style syntax. I don't think you do a single language in this program that's not C-style syntax. So it's to say almost nothing. Yes, large active community. Frameworks, Laravel and Symfony. Where is Symfony? Symfony, there you go. 4%, right next to Nuxt.js, which I presume is some adaptation of Next. Very nice. Yeah. Yeah. PHP is known for fast execution and optimized for web server tasks. Although Node is optimized more. So, the big takeaway, on a server, you can actually use pretty much any language. Like, you can get the task done with, like, you could sit down and write a server program from scratch in something like C, and you'd be able to eventually accomplish the task, right? But most of us don't have that kind of time, so you know, we use the things other people write for us. Okay. Here we go. PHP. It is my goal that by the end of this lesson, you shall come to hate PHP. Hopefully, by the end of the course, you will have like distilled that hatred into a fine crystalline form of hatred. Just hold that little crystal of hatred for PHP next to your heart for the rest of your lives. That is what my goal is right here, right now. Okay? So, let's compare basic things in a bunch of different languages that you hopefully know. So, declaring a variable. In Python, you just do it. You don't have to declare anything. Java, you must know the type. In JavaScript, you must know the scope. In PHP, you must use a $sign. The type system in PHP resembles JavaScript's type system, but it's a little bit better than JavaScript. A little bit, but not much. Let's review a couple of basic definitions regarding type systems. Can anybody tell me what a dynamic type system is? What does dynamically typed mean?
Something that can change.
The types of things can change. This is true. Of these languages, which of these are dynamically typed?
JavaScript, Python.
JavaScript, Python, and I'll give you PHP, right? Java is not dynamically typed. Java is statically typed. When you declare something as an integer, by gum, it's an integer. And anybody who says otherwise is wrong. Python is also a weakly typed language, right? Can anybody tell me? Hopefully you covered this in JavaScript. Oh, I just gave it away. JavaScript is a weakly typed language. What does it mean to be a weakly typed language?
It's not
Oh.
statically typed.
Sorry?
It's not statically typed, is it?
It's actually different entirely from static versus dynamic.
Okay.
Yeah, it's like a different axis. Yes.
I was gonna say that like you could have integers in a string and vice versa in a weakly typed language.
Not quite. Yes.
So this is just a guess. The compiler doesn't do anything when you want to change the data types? It doesn't like shout a warning of any sort?
So you're getting closer. So this is what it means to be weakly typed, right? Basically, the system performs a bunch of BS type conversions behind your back without your permission. That's what it does. So, for example, if I pull up the JavaScript interpreter, JavaScript also being statically typed, which of these am I going to get fewer errors on? Let's see. There we go. Right? 5 is, the integer is equal to 5 string. That wouldn't fly in Java, right? In fact, you may remember, JavaScript supports a triple equals operator. The triple equals operator compares type first. If there's a type mismatch, then it's false. Then it proceeds to test the value. Right? So it tests type first, then it tests value. Kind of gross and ugly, right? You want to see something that's even more gross and ugly? You can get JavaScript to violate basic laws of logic using this. Weak equality does not, it's like not properly math. So here's a law of logic that should be true. I hope we can all agree with this, right? If A is equal to B, right, and B is equal to C, what can we conclude? A is equal to C. This is known as the transitive property, right? It is important that this be true, right? Try to imagine a scenario in which A is equal to B and B is equal to C, but A is not equal to C, right? That is a strange definition of equality. Now let me show you how JavaScript, and in fact PHP as well, handles. Let me show you this. So 0 is equal to 0. Okay. 0 is equal to an empty string. Is an empty string equal to the string containing 0? Of course it isn't. So yeah, weakly typed languages. Here's another fun one for you. You know, not a number. You know it's not equal to itself? Imagine a thing that's not equal to itself. I don't think you can. Except for not a number in JavaScript. And guess what? Being strict about it doesn't help. Being strict helps here because it's comparing types, right? But that's a lovely little chestnut. So that's a weakly typed language, right? Weak actually strong. Python actually is a strongly dynamically typed language. So you see, dynamic typing and weak typing don't necessarily go together, right? There are languages that do one and not the other, like Python. Python actually has a very interesting type system. It's called existential typing, but don't have a crisis. So what it does is for everything, it maintains like a set or a pool of what the types of it could be, and when you use operations, it narrows the pool. And when that pool of available types becomes empty, it's like, that's a type error, right? So Python does in fact, like you can get Python to produce type errors, right? Anyway.
We're supposed to be talking about PHP.
So, semicolons are required in the same way as in Java. C-style comments, same as JavaScript and same as Java. Okay? PHP is an interpreted language. So here's an interesting thing. Do you guys know what a compiler versus an interpreter is? You know the difference between a compiler and an interpreter? This is like fairly important computer science stuff to know. I'm glad we're having this discussion. I'll do a diagram. Diagram time. So, let's imagine that this is your operating system. All right? In a compiled language, C, C++, fantastic examples, C# as well. Let's imagine we have a C file, a.c. In a compiled language, we have a process, a program running on the operating system, perhaps GCC, the GNU compiler collection, which is the Linux C compiler. You feed the file in, it produces an executable file. In Windows, executable files are generally .exe. In Linux, they're just executable. They generally don't have file extensions. Then, if you want to run the program, you take the executable file, and it itself runs on top of the operating system. Does this make sense? Okay. Any questions? Compilers? Now let's talk about how interpreters work. Python is an interpreted language. JavaScript is an interpreted language. PHP is an interpreted language. I'll get to Java. Let's say we have a PHP file, a.php, right? When we execute the PHP script, we do so on top of another process. In our case, the PHP interpreter, which is just called PHP, right? That's the executable name. So we take the file, we plug it into another program. That program feeds the file through itself like a Xerox machine. Well, like a fax machine. You know, any machine that takes a piece of paper and like rolls it through a roller and scans it as it's going, that's the type of machine I'm talking about. It scans it line by line, executes those lines line by line, and this thing takes input, produces output, right? The script itself isn't a proper program, right? It's not the thing that's running on the operating system. Right? Does that make sense? So, one of the advantages of interpreted languages is that you can have a stack here that's multiple layers deep, right? So, for example, if this were JavaScript, right? Your first layer is your browser. On top of that, you might have like the V8 Chrome engine for JavaScript. And then on top of that, you have app.js being crunched up one line at a time into the interpreter, right? So like you can kind of nest things into multiple layers where it's with an interpreter, whereas for these guys, they just run bare bones on the operating system itself. So these guys are faster, these guys are slower. This thing takes time and computation. This thing does not do dynamic checking. This thing does dynamic checking, right? That's why dynamically typed languages tend to be interpreted languages. Statically typed languages tend to be compiled languages. So you want to know how Java works? So, you have a process, this is all hidden by IntelliJ, by the way. You have a process called javac, javac, Java compiler. In goes your Java file. So far we're looking like a compiler. Out pops, and if you dig around in your directories inside of your IntelliJ project, you'll find these things. You'll find a class files. Post-compilation, but they're not machine code. You can't take a class file and run it on the operating system. What you require is the Java runtime environment, which is also sometimes called Java itself. You plug this thing in, and from that point on, it's an interpreter. So Java is both a compiled and an interpreted language. That's the Java runtime environment. This is the standard development kit, right? The SDK includes the compiler, right? Make sense? So there you go. Compiled languages versus interpreted languages. PHP is an interpreted language. It's so interpreted that you yourself, within the PHP file, turn the interpreter on and off, and it's by default off. Right? That's what this thing does. That turns on the PHP interpreter. That turns off the PHP interpreter. These are not, when these occur and there are multiple of them in a file, it doesn't mean you have different PHP sessions, right? It turns off PHP interpretation, but it doesn't remove the session, right? Your variable's declared here, right? If I declare x is equal to 5, right there, And down here, I'm like, you know, echo, echo, x. I have not committed any errors, right? Variables up here still exist down here. You can actually do some pretty crazy things with this, which we will get to. The way that most modern systems deal with what PHP is attempting to do here is by using what's called a templating engine. I'll show you quickly what a template engine looks like, or code written for a template engine. So that your education should not be lacking. I mean, you know, so that your education should not be lacking any more than your unfortunate choice of professor this semester. Not that you had much choice. I'm the only game in town. So there is a template engine called Handlebars. Let's see here. Sometimes if you give it an image, they'll just give you some code. Is this Handlebars code? No, that does no. Code example? Yeah, there you go. So this is this is what Handlebars looks like. This is what PHP kind of attempts to do with turning on and off the PHP interpreter. In templating engines, you'll have some kind of little syntax thing that's not like, it's not HTML, right? It's a syntax thing that's been layered on top of HTML, but it does something kind of programmy. In this case, the two the whiskers here, two of them like that, means this is a variable. Put the variable's value in here, please. Right? My name is name and I live in city, right? When you fire up the template engine, you would give it a bunch of variables and it would perform the substitutions, right? This is very possible in PHP. I even just do it here. So the PHP way of doing this is as follows. Hi, my name is PHP opening tag, echo, name, close PHP tag, and I live is, I think you mean in, PHP opening tag, echo, city, where city and name are like variables inside of PHP. The reason that semicolon is not required on the last line is so that you don't have to put it here. In fact, PHP provides a slightly abbreviated syntax for doing this. If you're just trying to echo a variable or an expression, you can put an equal sign there in PHP, and that's the same thing. That is the same as that. It's syntactic sugar. Question?
Yeah, the earlier thing about handlebars, this might be a bad question, but...
No such thing. Well, I know, there's totally such a thing as a bad question. But anyway, continue.
It looks similar to jQuery, is it?
Ooh, yeah, see a lot of them kind of pull on a similar pool of syntax. but jQuery is like attempting a abbreviation of JavaScript specifically, right? This is for HTML specifically, right? So you wouldn't. It would be foolish to attempt using these guys inside of like a script block. Yeah. Yeah. The purpose is to make like one version of the HTML, and you dynamically change parts of it based on data. Maybe this is data you got from a database, right? But this is what PHP, like this is what it's really for, right? What PHP really is it's a templating engine that's gotten uppity, right? It's integrated too much into itself, but really at heart it's a templating engine. Does that make sense? Cool. You want to see something a little crazy? Just a little crazy? I guess I'm going to have to use an IDE, huh? Use VS Code, use Notepad++. I don't personally care. There's a JetBrains IDE, which is probably superior to everything for PHP specifically. If you want to use that, I highly encourage it. I personally use Notepad++ for the specific reason that VS Code is bugged as all hell on Apps Anywhere, and it basically, there's this really awful recurring bug where like it will silently fail in the background and just stop saving documents, which is very frustrating when you're trying to teach a class doing code and someone's like, why isn't this code working? I thought I changed that variable name, and it's like, oh, it's just not saving silently in the background. So I'm sorry, VS Code. Notepad++ is my new girlfriend. If you want to know what I use personally most of the time, I use a program called Kate, which actually is the name of the girlfriend. How am I going to search it? What's the project, KDE? This is what I use, because I try to use KDE stuff whenever I can, because I'm a Linux guy, right? KDE makes all the best Linux software. It's true. If there are any Linux people out there, you know I'm talking truth. Plasma is the desktop environment that the Steam Deck uses. Kdevelop is trash, don't use it. Kdenlive is like very, very good free video editing. Krita is like as good as Photoshop. Lots of stuff. And the mascot's a little dragon. So anyway, that's what I use most of the time. It's slightly fancier than Notepad++, but it's kind of at the same level as Notepad++. Why do I care about baseball? I don't care about baseball. Go away. All right. So let's save a new file. Save as. In this thing, we'll save this as stuff.php. So PHP x equals 5 and PHP. Here's one for you. If x is equal to 5, which presumably it is, end PHP interpreter, launch PHP interpreter for the purpose of else. that works. This is PHP. Welcome to PHP.
Is that conditional rendering?
Let's see here. I need. Oh, unexpected diff. Nuts. There you go. So, I think I would kind of slightly object to the term conditional rendering. Because the browser is always the one doing the rendering, right? And this is not something going on in the browser. Note the state of the HTML, right? All that appears in the HTML is that heading. No if statements, no PHP code whatsoever, right? This is how it's coming pre-built from the server. So the role of PHP, it's basically a string processing engine, right? It's taking HTML, changing it, giving it to the browser, right? But critically, the PHP code itself never reaches the client. Never ever reaches the client. This is why it's safe to do things that sound crazy, like encode your database password in your PHP code. It's safe. All the PHP is stripped out before it's sent to the client, right? So if I go back here and I change this back, right? But like, it's really kind of complicated. Oh, Jesus. There we go. It's really kind of complicated to explain, like, what PHP opening tag, like closing curly brace close tag, does out of context. You know, like what is that even? You know, yes.
Does it just kind of ignore every other PHP open? Like, or does it just consider like top and the bottom? Like open PHP and then close?
The best way to understand it, and I'm sorry to do this to you, but the best way to understand it is that it's go-tos. Right? You guys know what a go-to is? In a way, it's good that you don't know what a go-to is. Go-tos are dark magic. They are the arcane arts of a forbidden era. Basically, if we consider how programs are loaded in memory, the program itself is in memory, but there's a variable that keeps track of what line you're on. Right? This is called the program pointer. Go-tos change the value of the program pointer. It's a basic operation. It exists in some languages, not in others, but it is a CPU operation. It's unavoidably a CPU operation. Java has go-tos. Did we tell you how to use them? Heck no. Because using go-tos results in spaghetti code, unreadable code. We put go-tos away like 30, 40 years ago. Nobody is supposed to use them. However, if you take an if statement, you give it to a compiler, the compiler makes that thing into go-tos. Right? So, this is what an if statement actually is. If x is equal to 5, if that condition evaluates true, go to this. Otherwise, go to that. Right? This brace is a go to that brace. If you hit that brace and execute it, you go to this one, and then you finish. Right? Go-tos. like the closing curly brace of a loop is a go-to back up to the top of the loop. Yeah.
If you had an extra line 9, would that result in a syntax error since there was no opening bracket?
An extra line 9? Yeah,
If you copy and pasted it?
like duplicate it.
Yeah.
Shall we see? There you go. Unexpected mustache. Yes. At that point is basically the same thing as doing this, right? But yeah. So the go-to operations that occur in PHP will skip over HTML, right? So it'll skip over everything, like it'll skip over things that are not in PHP mode, basically. It'll forward scan for the next thing that occurs in PHP mode and go for that. It's a bit weird, right? This is not how a lot of templating engines work these days because this is weird and clunky and nobody likes it.
It's just unreadable. It's just like unreadable.
Yeah, no, it strongly contributes to unreadable code. But you know, for many, many years, PHP got the job done. Also, programming languages don't die. Oh man, there's this meme I've got for other set of slides, and it's like 4 guys on the gallows, and 3 of them are like, I'm about to die! And it's like programming languages. It's like Java, PHP, and then COBOL's looking at them and saying, first time? Programming languages don't die. What happens is, any programming language that's sufficiently popular gets a code base. People get stuff to work in a language. The stuff working is useful and needs to be maintained. Nobody wants to re-implement it because it works, and there's no business case for there's no business case for the opposite of if it ain't broke, don't fix it, right? So all of this legacy code just kind of piles up over the generations. And did you know that Fanshawe College has a course on COBOL? You guys know what COBOL is? What's COBOL?
I don't know much, but I know it's used for a lot of stuff, so.
Yeah, it's like the back end of most of the bank servers in this country. Yeah. You want to see what COBOL looks like? We've got like 1 minute.
Is it worse than assembly?
No, it's not quite assembly. This is what a program in COBOL looks like. Woof is the right reaction. You have this very interesting period in computing in the 1970s and 80s when, like, businesses decide, ooh, data management, we could probably invest in that. That sounds like a great idea. Product catalogs and users and customer databases and databases, programs. And so a whole bunch of languages come out around this time that are like, the syntax implies that like they were designed for business people to be able to use. But here's the problem. To program, you must be a nerd. It is required, right? Business people generally are not nerds. They don't have the mathematical chops to be able to program, right? So what happens is they make programming languages like this. They fail to be able to operate them. They have to hire real programmers who hate languages like this. It's like, just give me curly braces, right? Don't give me stop run. Why is there English in my program? I don't want any English in my program. It's math. But, you know, oh, and by the way, you know, that's like an assignment operation right there. Move 30 to second number. second number is the variable, and move to is like assignment. That's equal sign for us, right? Yeah, so, but you know, this runs the back ends of the banking servers in this country. And therefore it has to be maintained, right? SQL, by the way, is also in this category of like these types of languages that business people, that are designed for business people. Like the design intent here is that it should look like an English sentence and yet be math. All right. Anyway, I think I've waffled on for, I've consumed enough of your afternoon. Thank you very much for your time and attention. I hope you learned something today. I'll be seeing you Monday. If you guys didn't get this impression already, this is actually one of my favorite classes to teach.